if if I have this polarizer and I put it out in front to you have to describe with a polarizer. You talk about extinction ratios. If I put them in together, how much light? Oops, I didn't do it together. If I do it together, how much light goes through versus if I cross them, how much light goes through. A reasonable polarizer's the extinction ratio is like 10 to the minus 4 or 5 or so. So going after you've gone through one polarizer, almost all of it's lined up along that direction.
But I'm just trying to understand
Yeah.
the physics, the actual polarization direction. When you put the 45 degrees, after one is already vertical polarized, how the 45 degree can.
So if you think of light polarized in this direction, as we just said when I first did it, so we have those two coordinates, right? And we said that light polarized in this direction was by having a combination of light in this direction and this direction that were in phase with each other. Okay? So now I have light along here, and I put it through a polarizer like this. I eliminate this part, but I still have that part. Okay? So it's almost like taking it to a new basis set, if you'd like. When I have it polarized in linearly here, you can think of it as a combination of this and this in phase with each other.
Yeah, but after you, let's say vertical.
Okay.
After you vertically polarize this, and then if you put a second step, you put 45 degree. So what does that actually do with it?
Take this picture and turn your head. Light polarized this way, now you can think of it as this way and this way in phase with each other. And your polarizer at 45 is going to eliminate one or the other. That make sense? So now light's polarized here. I can think of that as light being polarized along this direction and this direction, but oscillating in phase with each other. And so when it'll go up and down along this direction, like I said, but now I put it through a polarizer, say aligned here, that eliminates that one. And now everything's polarized along here. And now I go to my next polarizer that I put in this way, but I have light polarized that way. You know how they make these? It's a long chain polymer, and they stretch it out so they all align in one direction. So you have the things aligned like this, say. And so when light goes through it, the electrons are more likely to be able to move up and down like this than move that way. So if it's lined like this, which way does it let light through? Which polarization goes through? Polarized like that, because this way it's absorbed easily. So it only lets the light come through like that. So the light that's along the chain gets absorbed, and it lets the light this way doesn't get absorbed very well. Some of it does get absorbed, which is why these things aren't perfect. But yes, ma'am.
Will the polarizers be oriented on pace? Like
How will the polarizers be oriented on pace? It doesn't. If you okay, so there's two polar emitters on pace, and Emmanuel can correct me here. One of them, they're both multi-angle and multi-wavelength. One of them has 4 wavelengths, but a whole bunch of angles. The other one has fewer angles, but more wavelengths to work with. Now, it doesn't matter. All that you care about is that you have 3 different linear polars. If we're going to ignore circular, but I don't know if they ignore circular. Let's ignore circular. So you just need 3 linear polarizers. If one basis set is like this, and a set like that, and one like this. And if with those 3 signals, I can determine the linear polarization state of the light. Another polarization state, and I think this is the one they use because it's actually numerically a little bit better, is this way. 60 degrees, and then another one 60 degrees. It looks like 45, but this is supposed to be 60, okay? And that's supposed to be 60. So with these three bases set, you can also determine the linear polarization state of the light. If they're all if the intensity I get after all these polarizers is the same, the light was unpolarized. If it was the same this way and this way, I have to work through the math to see which way, whether it's polarized in this direction or anyway. But I could work through the math for you. Yeah, I don't want to do it here on the board, but basically this, you think of this as a basis set or this as a basis set. With the intensities you get after these three polarizers or these three polarizers, I can tell you everything about the linear polarization, as long as there was no, everything about the linear polarization. Yeah.
And so for the 4 filters per pixel that Riley was describing, so you have 3 basis sets in intensity, or do you have?
There's 4 different, so yes, you could do it with 3, but just for replication's sake, it's 4. I don't think, does the 4th really add anything?
It doesn't add anything but a redundancy. You know, it'd be bad. You could get a whole lot of information maybe if you had a polarizer every degree around, but you don't need it. So.
Sets of 3 pixels don't tessellate, I guess. Sets of 3 pixels don't fit together.
Right. So the nice thing with that is if you have 4 pixels, this one, this one, this one, this one, then you can determine the polarization for like there and here. I can do it with this one, this one, this one. They all overlap. Going around. Anything else? Oh, wow. Okay, cool. So there's polarization. You're all set up for Kurt.
10:30, start up at 10:45.
All right, everybody?